Mathematical functions can be really useful when describing the real world and figuring out things in the real world. And what you want to be able to do is look at a real world situation and write a function for it. The keys to writing functions really are figuring out the start value and the rate of change. That's whether you have a linear function or an exponential function. Let's do one of each. Remember, for a linear function, you want to put it in the same old slope-intercept form, f of x equals mx plus b. Let's look at this example here. You're driving your car at a constant rate. You start with 20 gallons of gas, and you use 3 gallons of gas each hour. Write a function for the amount of gas you will have, and after how many hours will you run out of gas? So remember, the keys are understanding the starting value and the rate of change. And really, b is the starting value, and m is the rate of change. So let's figure that out from the problem. So we'll do f of x, and here, what does x stand for? Right, it stands for the number of hours. And each hour, we use up 3 gallons. So that means we have negative 3 times the number of hours, negative 3x. And our starting value was 20 gallons. So there we have our function. Now, can we answer that question? After how many hours will you run out of gas? Well, what does that mean? It means the value of f of x will be 0. So let's go ahead and put that value in. 0 equals negative 3x plus 20. And then we can add 3x to both sides to get 3x equals 20. And we can divide both sides by 3 to get x equals 20 thirds, which is the same as 6 2/3, which in hours is the same as 6 hours, and 2/3 of an hour is 40 minutes. So you'll run out of gas in 6 hours and 40 minutes if you don't stop to refill. Now let's look at an exponential example. Remember, with an exponential function, you probably want to have your function be in one of two forms. Either f of x equals a times r to the x, or if it's a percentage problem, f of x equals p, the starting value, times 1 plus r to the x. So let's try to figure out which type of problem this one is here. If it's a percentage problem, we'll use this one. If not, we'll use this one. So let's go ahead and take a look. At a pet store, you buy 7 gerbils. The owner of the pet store warns you that your gerbil population will quadruple every year. Write a function for your gerbil population. So we need a function. How many gerbils will you have in 6 years? Okay, I don't see any percentage rate of change there. Instead, I see that word quadruple. So we're going to go ahead and use this form for the exponential equation. So let's go ahead and write out and see if we can understand what our starting value is and what our rate of change is. In this case, the start value will be a, and we know that we started with 7 gerbils. So we'll go ahead and write equals 7. And then the rate of change looks like it's quadruples. That means 4 times. So we'll go ahead and write 4 to the x. So each year we're going to times that starting value 7 by 4. Now, then it asks us how many gerbils will we have in 6 years. So we need to find f of 6. So that equals 7 times 4 to the 6th. We can use a calculator to do that exponential there, which is 7 times 4 to the 6th is 4,096. And when we multiply that by 7, we get 28,000 672 gerbils. Time to get a bigger house. So what did we learn here? Well, really, we want to pay attention to the starting value, whether we're in a linear situation or an exponential situation, and also the rate of change. Once you know those two values from your descriptions, you can simply put them into the standard form of your linear or exponential equation, and then you can figure out really important information like when you're going to run out of gas or how big of a house you need for all those gerbils.